All right, we will get started. Again, welcome to Applied Day 2022. We're so glad you could join us this morning for a presentation about our 3D printing capabilities and how we can use them towards engineering and architecture. We'll get rolling with the presentation here shortly, but first I want to give a quick intro of Applied. So since 1986, Applied Engineering has been providing high-quality engineering services. We can assist you at any and all stage of the product lifecycle, whether you need help with product design, simulation analysis, factory design, process automation, or just need an extra set of hands to get a job done. Applied is there for you. And then in addition to that, we also have our print and image team that provides high quality printing and scanning services for architects, engineers, as well as other people as well. During this session, please feel free to enter any questions you have into the questions box and we will address them as we go. All of today's webinars are being recorded and will be sent out via email, so you can rewatch them or share them with friends, colleagues, whoever. Yeah, so with that, I will pass things over to our presenters, Paul Bartron and Steve Thompson.
Hi, a little introduction about myself. My name is Paul Bartron. I'm the current director of the Print Image Service Department here at Applied Engineering in Fargo. Like Emily was saying, we provide printing services for architects, contractors, and then anybody else who would need that. We do anything from wide format printing to signs, banners, uh, 3D printing, obviously, which we'll be talking about today, and some scanning services. And then I'll go ahead and let Steve introduce himself here.
Hello, I'm Steve Thompson. I work on the business development side of professional services, work with a variety of customers. Been with Applied for over 20 years. So I've been fortunate to see us grow and the capabilities grow. And one thing that's grown over time is definitely the changes that you see in 3D modeling. Back from, in the 90s, it was all handcrafted. It was kind of a sport, an art, if you will. And now the technology is just amazing. So it's been fun to work with Paul on this presentation, just to kind of go through some of the overviews of where things are today. And so we'll kind of get into that. How we'll do this is just kind of a general overview. Paul will go through that of the different 3D technology, then how it can be used in architecture, which is pretty cool. It's again, it's just the technology has made things so much easier to do visualizations, actually make scale models and things that where it would take a great deal of time and huge budgets to do a lot of these things. Now it can be done very, very cost effectively and without a lot of headache. Then we'll go through some of the examples we've done with design as well as manufacturing, and then Paul will finish up with talking about some of the future of 3D printing. So should be half hour tops. We're trying not to take up too much time, but we want to pass on this knowledge as efficiently as possible. And like Emily said earlier, if there's any questions or whatever, just throw them out in the chat box, and we'll take them at the end, and we'll kind of go from there. So I hope you enjoy the conversation. This is meant to just kind of be thought provoking and just to get people in touch with some of the things that I'm sure most of you are familiar with some of it, but hopefully you'll learn a little bit. So with that, we'll let Paul run with the printing methods, and we'll go from there.
Um, yeah, so today I'll be kind of talking about the basics of 3D printing and the common types of 3D printing here, and how it's used in architecture. There's definitely different several types of 3D printing, and each one has its benefits. And there's always new types that are popping up here and there. But today, this kind of discuss the common, three of the common types of 3D printing, which is SLA, FDM, and SLS. So SLA, or they call it stereolithography, was the first type of 3D printing, which was introduced in the 1980s. It's still a very popular method of 3D printing, and it's still being used today as well. So SLA uses a laser to cure liquid resin into a hardened plastic. The model is adhered to a build plate that lowers into resin, and then which the laser hardens a layer of resin into plastic as the build plate rises, normally printed upside down. It's popular for its ability to produce high accuracy models with fine features and smooth surface finishes. It's widely used in industries such as engineering, jewelry, dentistry, product design, just because you can get a fairly accurate, smooth models out of this type of 3D printing. In the on the left-hand corner picture, there is kind of an example of SLA printing. Um, FDM or fused deposition modeling can also be known as fused filament fabrication. Is the most widely used type of 3D printing on the consumer level. So when you think of 3D printing, this is the one that kind of pops up quite often, or what most people are popular with, just because it's a low cost to get into. The equipment and the materials are low cost and pretty easy to use. Um, FDM works by heating filaments through an extruder and laying it out one layer at a time onto a build plate. Printing can use several types of filament, such as ABS, similar to what kind of Legos are made out of. PLA, which derives from a renewable or organic source, such as like cornstarch or sugar. Um, TPU is a thermoplastic polyurethane, which is a filament known for its flexibility and elasticity. So you kind of have almost a rubber texture feel to it, and has some flexible components to it. There's several types of filaments that can be used through FDM printing based on whatever needs you need for printing. FDM printing is well suited for basic proof of concept models, so they're known for simple prototyping. They're low cost, and they do typically print at a lower resolution in compared to SLA or SLS printing, but it's very popular because it's easy to use. There's a lot of free resources out there. Um, and this is actually the method we use here, and that's going to be displayed in the bottom middle picture. There is kind of actually the machine we use here at Applied. Um, SLS, or selective laser sintering, is 3D printing that uses high powered lasers to sinter small particles of powder into solid structures. So SLS uses a nylon powder material for printing. The benefit of it is the powder supports the parts during the printing and eliminates the need for dedicated supports. It's a popular choice for engineering because you can get uh, end use products of a printed products with a lot of functionality out of it, straight from the print. So these are the three most common methods of 3D printing you're going to see here today. Uh, So 3D printing and architecture and the benefits of 3D printing. So we've all probably seen the small scale models of buildings in some point of our lives. In the past, most of these models were scaled from 2D drawings and built using materials such as wood, ceramic, cardboard, or clay. Uh, this process can be very time consuming, and as we all know, time is money, and 3D printing can help reduce overall costs. Um, with today's technology, 3D printing can be used to reduce time required to build these models and allow for the ability to create intricate and accurate 3D models with 3D printing. With nowadays, you can convert 2D drawings or 3D models created in CAD software and have printed straight directly to 3D printers. By allowing 3D printers to do all the work, you can focus your time on other projects or different projects entirely. 3D printing allows for architects to print precise scaled models or even add intricate models, details to models that can't necessarily be done the traditional way. They can also easily alter or make changes to a model by 3D printing newer pieces or additions. Um, as 3D printing advances and adds cost and time reducing benefits, you'll find more and more architectural designers firms using 3D printing as a helpful resource and tool. Yeah, you got the next section here.
You bet. Um, Interesting little backstory. When I was first went to school, or college, I should say, one of my specialties in that time frame was model building, which was prior to stereolithography. That type, it was stereolithography was pretty new, but I didn't think it was going to replace it. It used to be its own whole new market. And by the time the technology changed so fast that by the time I started college and by the time I finished, the that art form had kind of gone away, which was a rude awakening for somebody who just went to college for that. And so I've always had a keen interest on the advancement of that, and in the architecture world, that's a huge, like Paul was talking about, that was a huge tool for visualization. For most, I would say most people can't visualize from a 2D print into a 3D building. And so that visualization is critical for people, designers, you know, everything, because you can just lay everything out at scale and really get a good refinement of the product, as opposed to waiting till it's built and then realizing there's things wrong. So it's pretty crazy, pretty fun. But as far as in the design side, um, SLAs is what I started with, doing that fit and function within machines to do parts, custom parts, especially plastic parts that were going to be molded to the tune of, $50,000, $100,000 in tooling. You better make sure it works the first time. So that's a huge part of it. In SLA, even the SLA costs have gone, it was in the mid 90s, it was, the budget for doing these was in the thousands of dollars. By the time the end of the 90s, it was hundreds of dollars. And now, doing 3D printing, it's even, you know, hundreds of dollars is very heavy on that. So, I mean, I've got down considerably from that. So this technology is fantastic. Um, you can you know, do changes a lot of times within our world. A lot of times just to take the concept, getting it into something functional, somebody can touch and feel and look at and try is incredibly beneficial. And inevitably, it leads to additional iterations, refinement of the product. We've been using, even before we bought a printer, we were using it services regularly, just because there is no better way to check fit and function, visualization, just to kind of get your hands on it. And so, I mean, you can look at it in a variety of different ways. I like the picture on the center bottom. You can model that until you're blue in the face, but until you print it and put it on, it's then you can know for sure that it's going to work. A lot of different things are marketing, as far as the center picture with the helmets. That's a great tool to quickly get some iterations of different looks and feels and styling off the computer screen and into people's hands, as well as, you got the engine block on the left side there. That's obviously the complexity of that, the fit and function. You're going to be doing those in large molds. You have to do something, and a machine something like that would be incredibly expensive. Uh, but you need to have it done to check your design, uh, regardless. And so the 3D printing is just fun. We're doing one right now with a customer who had a concept. We just kind of quickly came up with a model, pretty simple tool. Now Paul's going to be printing it here shortly, if he hasn't already done it, and it'll go from concept into something in someone's hands in a matter of a few hours in real time. And so it's pretty cool. That's just not possible without a lot of this 3D printing technology, and at a cost it's so much more affordable. I know, as far as Letspot, uh, they print a lot of their parts for the machines, which is kind of almost like a Terminator thing, where you get AI going within these machines. They could design and build their own themselves and take over the world. But it's really neat the time of that a lot of advancements we've seen, as Paul mentioned, on the materials. There's even some, you get into the high end, it can print metals, which is crazy. But there's a lot of different technology, and it's not um, just for, iterative design, but it gets into manufacturing as well. A lot of areas that we see it. The kind of a good shocking one for me was is one of our customers uses them for assembly fixtures and things like that, which isn't shocking at all. That totally makes sense. But in the past, you've always, anytime you design things, you had to design it to be manufactured. So you couldn't have blind spots where you couldn't get if you're going to weld some things up, where you're going to, couldn't get a weld head in there, or, if you blind holes or different things like that, you couldn't do because you couldn't manufacture it. Well, 3D printing of these fixtures doesn't care. It gives you a lot of freedom to design it however you want, because of the simple fact that it's just going to print it layer by layer. There's not going to be machine, you're not going to need tool access to get in there, different things like that. So the traditional design skills needed for like manufacturing fixtures, different things like that, aren't necessarily needed, which is kind of uh, exciting, but it's also a little bit scary too. But um, you can just kind of do what you want to do. You find your surfaces where you need contact and go down from there. It doesn't matter if there's undercuts and different things like that on the part, because it's just going to print it out. So it's really pretty cool. That as well as, like I mentioned, Lutspot prints out a lot of their parts for the machine, as well as other organizations use them for anything. I've seen them for uh, simple protection for shipping, to little buffers and little tools that are put in kits to help customers. There's just a ton of opportunity there for advancing the, your product and quality by just printing out a few different things to guide customers, templates and different things like that, that normally be just made out of paper or something like that, where you can do a 3D print of it. Doesn't cost much and helps out a lot. uh, Here's some examples of production parts that are made on the upper left there. It's pretty, it just doesn't even make sense. You don't need to make a, if you don't have a high quantity of parts that are going to be made, if you look at some of those parts there, if you're going to tool those up, say for injection molding or something like that, you're going to look at several $1,000s. Well, if you're only going to make 100 of them, to advertise that cost of tooling in there just doesn't make sense. Parts would be too expensive. It's far cheaper to print them, and then you're done. You don't have it, extra tooling and different things like that. So for low volume, it's a really good resource. And then a couple more examples there of intricate fixtures that were printed, and whether it's simple or complex, uh, it's just a nice way of, you have your digital model already in the software, whatever CAD software you're using. You just slap the fixture underneath it. It's going to touch all the right surfaces. You just extend it or whatever you want to do to those surfaces, offset them. You get your surface of your model of your fixture, and then you go down from that. Support it however you need. Whether the picture in the center and the bottom is using Costco clamps or whatever, but you could, hydraulics, pneumatics, whatever you wanted to use, put that in there, and in a very cost-effective and time-effective way, you can grab that surface. You're not doing, high precision machining on big fixtures to get your spots or touch spots or whatever, depending on the situation. They've actually been used in welding fixtures, which is a little bit spooky. But if you take consideration for the heat and you're not directly on underneath a weld or different things like that, it works fantastic. So it's pretty crazy, all the options that are opened up. I know a lot of you may already know all this stuff, but to look at it as a whole picture, as a whole um, avenue for helping on production parts, manufacturing parts, and design, architecture, and things like that. It really is pretty amazing, the technology, and it's also changing very, very quickly as well. That technology just keeps advancing. So, um, but right now we've really hit an inflection point where it's very, it's the market is there for many, many different options. So it's pretty cool. Paul will probably jump on this one. He'll talk about some of the future of printing, and we'll go from there.
Sure. Thank you, Steve. Um, So yeah, kind of as Steve was talking about there, most people are pretty familiar as far as 3D printing goes on a smaller scale, whether it's on the consumer level, manufacturing, or design. We've always talked about 3D printing as far as creating manufacturing parts, prototypes, smaller stuff. So what does the future of 3D printing look like? Well, there's been an ongoing, growing interest on new technology in 3D printing for construction and architecture, from what I've seen, and it's actually already happening out there right now with several companies have invested a lot of research and time in 3D printing method for constructing buildings and homes and structures. Uh, they can use 3D printed structures or building components at a warehouse, for example, on the right-hand picture there, or they can use a large machine similar to the FDM method, and they can print walls one layer at a time, utilizing materials such as concrete or any alternate carbon-friendly materials. So it's kind of a nice feature there. Um, some of these structures can actually be printed within 24 hours, greatly reducing the time it costs to construct a building, or even reducing the number of materials and labor needed to finish construction. That's a huge benefit when it comes to construction, is time, cost, and money. Being able to do that so fast with 3D printing could pretty much revolutionize how we build buildings in the future. So with 3D printing, the way it's done, you can actually it allows for new structural designs, which could be more efficient than how we traditionally build things as well too. As if the efficiency and benefits of 3D printing improves the construction architectural industries, this might become a standardized way of how new buildings are going to be built. So here's a couple of examples, as you can see here, where they do 3D printing houses, but using a concrete material. They can set the machine to go, and then you have your general contractors come in and set in the windows, the plumbing, and the architectural as it goes, and you can have a full structure home built within a couple days to a week. So this is kind of where the future of 3D printing kind of is lying there. So, but that's what I got here for our time today on 3D printing. If you are interested in any of our 3D printing design services, or would like to talk about 3D printing, you can go back and review our slides here. Our emails are in here as well too, and feel free to reach or contact us. So,
All
Emily,
right, thank you, Paul and Steve, for that wonderful presentation. Sorry, Steve, did I cut you off?
I was asking if there's any questions we wanted to address.
Got it. Yeah, no, I don't see any questions in the questions box. If anyone has any, while I'm kind of giving my little outro spiel, please feel free to put those in there, and then we'll tackle those right at the end here. But in the meantime, I just want to thank everyone for joining us today. We have 2 more sessions this afternoon. The first one is focused on FEA and simulation, and the second one is on the software development side. So those should both be great presentations to tune into. Again, these sessions are being recorded and will be sent out to you via email, and they'll be on our YouTube channel as well. Yeah, so I don't see any questions coming in, so we will wrap it up for today. Again, thank you, Steve and Paul, and to everyone who attended.
Thank you very much.
thank you.